take them and upload them
Okay, so
this evening when I get home.
I'm going to show you how to do this workforce assignment. Has anyone started on it?
Oh, do they need to have paper?
Isn't it on Blackboard?
No, it is.
Yeah.
Yeah. If you go to
This-
Blackboard in week 2, the work and force and work done assignment is in there and it looks just like this.
It's in week 2.
Week 2.
Do you have it? So you may not know what is for work done, how to calculate force, but all the equations are given. So what we are trying to learn here is how to apply an equation and write a code to that so you can use it for any situation. So for example, if you look at the problem is you have a block of mass, M. M can be anything, but it's in pounds. So it can be, for example, let's take the numbers that are given here, 20.3 pounds. So let's look at a mass that is 20.3 pounds is being pushed across a horizontal surface with a constant acceleration a. So it's being pushed with the acceleration 12.3 feet per second. These are different units. 12.3 feet per second. The goal is to convert these values to SI units and calculate the net force acting on the block and determine the work done. So let's say you don't know how to calculate the force or how to calculate the work done, but equations are given. Here is Newton's second law says that some of you may have done this before, F equals ma. Are you familiar with F equals ma? So you can calculate the force done on an object by multiplying the mass of the object and the acceleration by itself. But so once you find the force, then work can be calculated by multiplying that force over the distance. On pushing an object with a force over a distance, so force times that distance travel will give you the work done. But the problem here is we don't know the force. What they have given is the mass of the object and the acceleration. Simple equations are you can calculate the force by multiplying the, there's a typo there. You can calculate the force by multiplying mass and acceleration.
What's the typo?
I think this is wrong. We don't need that. This should be mass.
Oh, see, I ignored that because that's came with the document.
And work done is this. The first step is, now all these are done in SI units, but what were the numbers that was given? What were the units of the numbers given?
Their feet pounds.
So mass was given as did you understand the problem? What we are going to calculate is the work done by pushing this object over a certain distance. Okay. So I'll just randomly put some numbers. Let's say mass is 20.3 pounds and acceleration is 12.3 feet per second squared. We can calculate the force by multiplying mass and acceleration. So if I want to find the force, if you multiply these two, you will get a number, but it will be in units, pounds, feet, and second, because those are the numbers we have, right? But I want it in Newton. Newton is when you consider these, not these units, but the SI units. So I need to convert this into kilograms. I need to convert this into meters per second squared. To convert this, let's see how we can do a unit conversion. If I have for mass in that same document, I have given the unit conversions as well. We know 1 pound is equal to 0.454 kilograms. Then how do I calculate 20.3 pounds? I just need to multiply 0.454 kilograms by 20.3 pounds. That should give you, oh, sorry, hold on. We are doing a unit conversion. So 1 pound is that. So to find this is the kilo. I know 1 pound is that many kilograms. Do you remember how to do the unit conversion? I need to do 20.3 pounds. To convert this, I need to multiply this by the conversion factor. I need to cancel out pounds, and I need kilograms. So pounds go at the bottom, kilograms go on the top. Now, this is our unit conversion. I can use 1 pound is equal to 0.454. You can do it the other way too, because I have this unit conversion here as 1 kilogram is equal to 2.205. So I can use that numbers too, but then it will go 1 kilogram is equal to 2.205 pounds. It's the same thing. Now, once you do this, you can calculate your mass in kilograms, because pounds cancel out and you will have kilograms. So same way, you can now convert the acceleration. The conversion factor that is given, did you see that conversion factor is given in the assignment? So go and find out the conversion factor. I have 1 meters per second.
All the conversion factors should be right next to each other.
3.28084 feet per second square. Oh no, that's meters per second. We cannot use that. We have to use this conversion factor.
Oh, go ahead and go back into the, no, go down. There's one that actually says the same name.
I have
Force and work.
1 feet is equal to 0.3048 meters. So if I have acceleration 12.3 feet per second squared, I need to convert it into meters per second squared. Second squared is okay, right? Second squared, I don't have to do anything. All I have to do is convert feet to meters. So to convert feet to meters, feet should go at the bottom. Meters should go at the top. And I know 1 feet is 0.3048. Feet cancel out. I'm left with meters per second. So that's how I convert first. Once I convert, I will get 2 numbers. I thought I brought my calculator. It's my calculator. So 20.3 times 0.454. This gives me 9.2162 kilograms. That's your mass. And here I have 12.3 times. A is equal to 3.7904 meters per second squared. So with these 2 numbers, can you tell me what the force is? How can you calculate the force?
Mass acceleration.
Mass times acceleration. Just multiply those 2 and that will give you the force. And that will be in newtons. Force is equal to mass times acceleration 9.2162 kilograms and 3.74904 meters per second squared. That would give me 34.5519 kilogram meters per second squared. Instead of this, we can use Newton. That's the Newton. Okay.
I think the assignment says joules in it for whatever.
Oh, that's the work done. We have one more step.
Oh, okay, sorry.
Then
It probably does have newtons in it.
Then we have work done is calculated by force times distance. So force is given as 34.5519 Newton. And the distance is given as, let's say distance is 25 feet. How do we convert feet into meters again? You take 25 feet. Use the unit conversion factor. I need to get rid of feet. It goes on at the bottom. Meters go on the top. One feet is 0.3048 meters. If you do that, 25 times 0.3. 7 meters. So multiply this by 7.62 meters. That should give you 34.5519, 7.62, 263.285 Newton meter. This Newton meter is same as joules. Now, if you are doing a calculation like this, did you see I need numbers? So for each different number, now I have to keep calculating all this, right? So this is where programming comes in handy. Instead of doing each calculation separately, instead of doing all these separately, now Mr. Loring is going to teach you how to put a variable. So no matter what numbers you pick, you'll always be able to find the work done. Do you want to?
Yeah, that's what we're gonna do.
Do you have any questions of this? What if you knew the work done, you knew it went over 25 feet, how would I calculate the force? I know the work done is 263.25 to push something over a distance of 25. So how much force did I apply? Yes? How do I calculate that?
Work done divided by the distance.
Work done divided by the distance. So if I know this, work done, I know this, but I need to find this, then I have to divide both sides by D. That will give you force is equal to work done divided by the distance. So you can calculate any information you like just by changing one equation. So again, with programming, you can put any number you want for any situation and calculate the answer. So each of you will have different force applied, different masses, different accelerations, and different distances, right? At the end, you will have different numbers, but the calculations should be the same at the end. Okay.
Okay.
Any question on how to do equation like this? So if you're not sure, just do it by hand and then write down the equations and he'll teach you how to enter the equation, right?
Yeah, that's what we're gonna start with.
Oops. Oh,
I think I will. Does anybody need to still say this? Everybody got what you need off of this?
You want to say it?
I could.
I don't know.
I don't know that it'd do me any good.
Probably they don't use it. It's a simple equation, right? It's multiplication. I think next assignment, it will have additions and subtractions as well.
And you'll be given less of, oh, we should stop the recording because it's gonna be different. Be different.